Hey guys, this is Coach Lowe, and we're going to talk about triangles in the coordinate and coordinate proof. So, as we look at this, we're going back to the coordinate plane, back to some graphing. This is Geometry, Chapter 4, Section 8, Triangles and Coordinate Proof. So, we'll look at some proofs in class, but first we're going to talk about just putting triangles in the coordinate plane, really without points, just kind of looking at expressions, things like that, where we can just pop these into the coordinate plane. So let's look at this first one. It says position and label each triangle in the coordinate plane. Right triangle FHG. So first we know there's a right angle with legs A units and B units. Okay, so let's talk about a right triangle real quick and then figure out how are we going to put this in the coordinate plane. So we have a right triangle. We know that when we have that right angle here of the right triangle, these are called the legs. This is called the hypotenuse. All right, so legs would be this side and this side. So now let's stick this in the coordinate plane. So here's my triangle. I have a right angle here, and I have a leg that's A units away, so that means this distance is A, which would make this point 0A because I didn't go left or right any. And this distance is B, so that would make this, the coordinates of this point, B, 0. So that's the first triangle. A right triangle with legs of length A and B make those points 0A and B, 0. All right, let's look at the next one. Isosceles triangle. We know what an isosceles triangle looks like. We have legs that are the same length, and then we have a base. All right, so as we're thinking about this, this is our base. We have base angles. This is a leg. This is a leg. So let's see what they tell us. Isosceles, KLP with a base KP 6B units long. So here's my base KP. I should have labeled that other triangle, and this would be L. And this base is 6B units long. So let's go ahead and put this in the coordinate plane. So isosceles triangle. If my base is 6B units long, that makes this point 6B, 0. What if you said, well, I didn't put mine there. I actually put mine here, and the center bisects the middle of that. That's totally fine. This side would be 3B. If we started right here and let's say the y-axis ran through, this would be 3B and this would go to negative 3B. That would be totally fine. This is 0, 0. And they didn't give us the height, so we'll just leave that alone. All right, isosceles AND with the base AD 5A long. All right, so let's go ahead and draw this one. Sides are equal in length, 5A long. So this would be 5A and 0. And that would be 0, 0. We would know that this point would be halfway, but we're just going to leave it at that. All right, let's go to the next one. All right, they are giving us triangles now, and we are going to find the missing pieces. So where there are question marks here, we're going to fill it in. So I have a triangle, C is 0, 0, and then I have 2A, 0, and then I have 0 something, but I'm noticing there are markings here which make these legs equal in length. All right, so let's check this out. If these legs are equal in length, then I know the height of this. That means this length is 2A, just like this one is 2A, which makes this point 0, 2A. Good job. All right, you can pause and try the next one if you'd like. All right, so now that you've tried this, let's see how long this is. We know the second coordinate is 0 because it doesn't go off of the x-axis, so it has no height, no up or down movement. All right, but how far over have we gone? Well, 2A is right in the middle, So if this is 2a and we go 2a more, 2a plus 2a is, yeah, good job, 4a. Good work. All right, let's try 2 more examples and then we'll be finished. All right, so go ahead and pause the video and try these. All right, cool. Now that you're back, let's get these rolling. All right, so I have not moved over any. So the first coordinate should be 0. We're only moving up to this coordinate. And then how tall is this? Well, this is 3b units long. There are no markings on this. So let's just go ahead and mark these guys and we'll just say that they're equal. So I have 0 and 3b. Those are equal to each other. We'll make that an isosceles triangle, won't we? An isosceles right. All right, if they don't give us that, then is there a way that we can find the height? Well, really, they haven't given us enough information. If they gave us some angle measures, we could use some trig stuff. If they gave us the hypotenuse, we could use Pythagorean theorem, but we really need more information to be able to find the height of this triangle. All right, let's go to the next one. So we are looking at an isosceles again. We know the base angles are congruent. We also know that these legs are congruent. We've gone out a units in the negative direction, so I have negative a0. We've gone out a units in this direction, so I have a0. Could I find this height? Can I find the height of that triangle? Well, we know that it's 0 something, and we could put b there. It's some distance up. We could also stick a b in here. We could, or let's do a. Let's use a different letter. I think there's already a b there. Some distance up this direction. Now, there are some things we know if they give us base angles. Again, we could use those to find this height. All right, guys, that's it for sections 8 in chapter 4. It's the last section in this chapter. Whoop, whoop. So I will see you guys soon. This is Coach Lowe, and I'm out.